differentiate the left-hand side and I'm going to differentiate the right-hand side. There is no way I can solve for y. So this is the product. So function 1, function 2. First function prime, 2x times the second one plus the first function times the second prime, but that is dy over dx. Plus, that is straightforward, 6x. But this one isn't, because I have to write negative 12 y squared times the inner function prime. And that equals 0. And remember, I'm after this. So I will keep dy over dx on one side, and I will ship the other two terms to the other side, but I will also factor out x squared minus 12y squared dy over dx equals negative 2xy minus 6x. All I have to do is divide by this. So then dy over dx equals this top, negative 2xy minus 6x, over this, x squared minus 12y squared. Is this okay? So let's go back and see if we have any questions.
So just to be clear, this is
Yes.
a dumb question. Whatever you're moving to the other side will become negative, right?
If it's negative, if it's positive on this side. But if it's negative on this side, when I ship it to the other side, it will be positive. So the way we remember it is, if we move a term from one side to the other, what happens is we change its sign.
Then can we do the one from the exam?
Yes. Any questions on this?
You decide to keep the x squared and minus 12y squared because their terms were the same, they were real square. It's on the left.
No,
No,
because
because you're solving
because they have the variable.
Oh, they're the ones, okay.
So that's why I have to keep these two, because they have the variable and I have to factor out the variable.
Okay, gotcha.
So it's x squared minus 12y squared. Better?
Okay, yes.
Everyone? Yes. Can you dictate that, please? The one from the test.
Oh, sorry.
No problem.
It's xy plus y squared minus 2x equals 0.
Perfect.
And the point is 1 negative 2.
1, negative 2. Very good. So here we were not asked to evaluate, but here we are. Product rule. First function prime is 1 times y plus x times dy over dx. Minus 2, plus 2y dy over dx minus 2 equals 0. See if this is okay. Is everything okay here?
Yeah.
Everyone?
How are we, I'm sorry. Do we learn this on Tuesday? I'm so confused.
No, this is old.
This is from
Okay. Yeah,
This is from,
this is from chapter 2.
really?
Yeah.
Okay,
Yeah,
so
it's 2.8. I
This is
noted
on
it.
the
I've been
second.
struggling with it for like a week. and I'm
how
still
are we
trying to-
deciding which one to differentiate? Like,
With the dy
With
over
the-
x?
yeah.
That's my question too.
because
Like,
y is a function of x, so it has to stay as dy over dx. And then after you do the first step, you want to get the two that have dy dx.
yeah, no, I understand that, but I'm saying like, why couldn't we do dy over dx with that y, and then
With y squared,
You may just solve
Wait.
it. from there.
So this is the product rule.
right?
I
Okay,
cannot just pick something out of the blue, right?
yeah.
The first function prime is 1 times the second one plus the first function times the second function prime,
Is that your question?
right?
Oh, because it's a function of.
Plus, we differentiate the function to a power. 2, we subtract 1 from the power times the inner function prime, which is dy over dx. Then negative 2x prime is negative 2, equal symbol, and 0. We got it?
Yeah.
Okay, so now we have two terms with the variable. They will stay. I will factor out. I have x plus 2y, and then I move y and negative 2 to the other side. Everyone with me now? Perfect, excellent.
If x plus 2y dy over dx and then equals,
X plus 2y, indeed, dy over dx equals 2 minus y.
Zero is the constant when you differentiate it, it'll be zero.
oh, gotcha, okay.
So then dy over dx equals 2 minus y over x plus 2y. And now I can write x equals 1 and y equals negative 2.
Could the numerator be y minus 2 instead?
If you put a minus in front,
So negative y minus 2.
that's fine.
Okay.
So then when we plug in 1 and negative 2, we have 2 plus 2, and we have 1 minus 4, which is 4 over negative 3, or negative 4/3. So that's the value of the derivative, although we don't even have the function. The value of the derivative at the point 1, negative 2. Is this better?
Yes.
We need to practice some more. We need to choose another. Are we okay?
No, I'd like to do it.
Yes, please choose any.
Do you want the one from the,
Anything you want.
from the practice? Oh, I did.
Emily, are you okay?
Good.
They didn't have any energy drinks in the thing downstairs. I was disappointed too.
Everyone is tired at this point. So.
I was up till 2 making a Jeopardy game for my main case today. It's fun. I love this. It's great.
I do not miss that class.
Okay, do we have another?
Yes.
Please, I'm ready.
On page 279, number 10, it's x cubed minus x squared y squared equals negative 9.
Excellent. This is a function, this is a variable, but this is a product of two functions. So let's differentiate the left-hand side, differentiate the right-hand side. What do we write for the left-hand side? Do you want to work on it for 1 minute?
Yes.
Okay, so let's work on it for 1 minute. Please stay awake. 15 minutes, please.
So there's not gonna be any more new material for the final, right?
No, this is it. We're done.
And then, did you change the due date for the test, the second test?
I didn't send it. I'm going to send it tomorrow, and it's due next Saturday.
Next time. Okay.
Anytime in the testing center. Yours and Brian's will be in the testing in Agronomy.
Okay.
But don't go tomorrow.
No, well, no.
Oh, okay.
Well, I can't, yeah, I can anyway. They close early.
Only because you may not arrive there.
Okay.
Same with on Saturdays here, they're only open till noon, I think.
Number one.
Maybe 1.
Okay, ready?
I think so.
So what do I write?
Is that 3x squared
Yes?
minus 2x y squared and then minus x squared 2y dy dx?
Awesome.
Is it 0?
Good. So in this case, I only have one variable. I'm going to move this to the other side to make it positive. So 3x squared minus 2xy squared equals 2x squared y dy over dx. And I'm solving for this. Well done. So please give me the final step.
Just divide by 2x
Exactly.
squared y.
Exactly. Very good.
Where did the negative x squared, okay, there it was.
No problem. Okay, what else would you like to go back to?
Can you do
Yes,
number 5 from the test?
yes. What does it say?
Uh,
You can. Oh yeah, so we have 1/x, 1 and 0.2.
Probably really
If you remember.
the derivative.
Okay, so remember we are asked to find delta y, which is always f of x plus dx minus f of x, and dy, which is always f prime of x dx. So all I have to do is just plug it in. So f of x plus dx will be 1 plus 0.2, and I plug in here 1.2. Here I plug in 1. So this is 1 over 1.2 minus 1. 1 over 1.2 minus when I plug in 1. For this one, however, I have to find f prime first. So f prime of this function we know is
Number 2 square root.
negative 1 over x squared. So in this case, this piece will be negative 1 over 1. And dx is 0.2. So this is negative 0.2. And this is 1 minus 1.2, because I have to find the least common denominator. So it will be negative 0.2 over 1.2. So this is the exact difference, and this is the approximation using differentials.
So if it's asking you to estimate,
This is the estimate, and this is the exact.
so that's
Yeah, because that is exact. F of x plus dx minus f of x. This is an approximation using the derivative.
okay. I was just looking at part B of number 4 because that says use marginal cost to estimate. So then you would use the second.
Correct. Yes. Good. Where do we go now? So we are okay with the linear regression, are we? Is that a yes or
I'm sorry.
with the linear regression 6.4 with the table, or do we need it or not?
Just do it, we got this one.
Okay, yeah, I just want to use the time for what you want. So let's look at number 9 on page 554. And we are given number of years since 1997. So x equals 0 is 1997. And we're given 0, 10, 11, 12, and 18. And correspondingly, minimum hourly wage. Minimum hourly wage, 5.15, 5.85, 6.55, 7.25, and 10.10. So we put the information in the calculator. So please go to Stat and Edit, press Enter. Clear if you have anything in there. Okay, it's not doing anything. It's frozen. So in list L1, please edit. So stat, edit, clear if you have anything. Okay, so let's put the list. So I have 0.
You don't have the calculator on.
Oh, of course I don't. Sorry. So 0, 10, sorry, 10, 11, 12 years from 1997, and 18 years from 1997. Okay. So 1, 2, 3, 4, 5. Yes, correct. 515. No. 5.15. 5.85. 6.55. 7.25. And 1010. And we are told it's linear regression. So get out of there with second and quit. And go to stat, go to calculations, and scroll down to the first linear regression, number 4. Press enter. No, it's not list L2 and L2, it's list L1 and L2. And now I want to calculate and give me the function. And the function is 0.2569 plus 4.359. So y equals 0.2569x plus 4.359. Part B. Use the regression line to predict the minimum hourly wage in 2020 and then in 2025, assuming the trend continues. So how do I determine what happens in 2020 or 2025? Yes. So I have y when 2020. Remember, the reference is 1997.
So it's 23 years.
Very good. So 0.2569 times 23 plus 4.359. And the other one will be y equals 0.2569 multiplied by 28 plus 4.359. And let's see what we get. What did we get?
10.27.
10.27 per hour. And for the other one?
11.55.
Per hour, assuming the trend continues. That was all I'm going to ask from 6.4.
And how do we make the ones on the calculator?
You go to stat
Mhm.
and you edit and click on edit.
Oh.
So in the first list you put 0, 10, 11, and in the second list 5. So we know how to find partial derivatives. We know how to find max min of functions of several variables. Do we need to practice differential equations? 5.7.
Sure.
Okay. Do we need to go back to integrals? Definite or indefinite? We have 5 minutes, so let's use them. What would you like? Do we want integration? Do I get to choose?
Sure.
Okay then. So I will choose 49 on 422. And that is the integral from 1 to 4, 2x plus 1 over x squared plus x minus 1 dx. Whenever we determine a definite integral, the function must be defined on that interval. So if x squared plus x minus 1 is 0 on the interval 1 comma 4, we cannot calculate in this way. Okay? But this will not be 0 between 1 and 4. How do I know? Well, if I solve this equation, negative b plus or minus b squared minus 4ac over 2a. So this will be negative 1 plus or minus the square root of 3 over 2. So if I approximate this, first of all, one of them is a negative number, and the other one is negative 1 plus 1.73, so it's 0.7 divided by 2, which is below 1.
Isn't that 5 square root of 5?
Yes, it is. So I want to calculate now because 1 is negative. We're not going to calculate the negative 1, but I want to calculate the positive one. So negative 1 plus the square root, thank you, Patty, the square root of 5, and close, and divide by 2. If this happens to be between 1 and 4, we can calculate this integral, but it's not. And the other one is negative. So yes, we're on the safe side. Good. So 1 is less than 0, which doesn't count. This is 1 to 4. And the other one is 0.618, which doesn't count. It's not between 1 and 4. Okay, very good. So then what do I do? So let's look at this and say, I wish something would disappear. What will you, and this is not a scientific way, but
It's dx squared.
what would you prefer to disappear, it to disappear? No, that will not help. Even if this disappears, I still have 2 terms in the denominator. It's still complicated.
So 2x.
2x is such a nice number, a term, and it's at the top, so that's not a problem. Exactly. Let t be x squared plus x minus 1, assuming that dt is in the problem. Because if it isn't, then I'm on the wrong track. Is dt in the problem?
Well, there's a t.
Yeah.
Well, once we calculate what it is, it's 2x plus 1.
Exactly, dx. So this whole piece is changed into what? Exactly. And this whole piece is changed into exactly. Don't rush. However, why?
We can't keep the
Exactly, we cannot keep the same